Hello and welcome to this mini course about Python for data handling. In this mini course, we will talk some about Python concepts and Python data storage abstractions, which are Python constructs that are able to hold objects in a similar fashion as collections or containers, or as a real-life example, you could say bags for items. These Python data storage abstractions, or you could say Python data structures, are used to store Python objects or data items. Consequently, these Python data storage abstractions are used within data science, data analysis, and machine learning all the time, because in Python, every number is an object or item, and the data storage abstractions provides a way to manage and control your data objects, items, data, and values. Therefore, it is very important to understand Python's data storage abstractions for data handling purposes. So, let's dig in with some details and an overview of this part of the mini course. So what is Python data storage types? And we can say that Python uses native data collection data types to store objects such as Python integers, floats, strings, or other custom-defined objects. And these defined objects can be files, images, or any Python native user-defined or program-defined object. And when we say that a data storage abstraction is native to Python, we mean that they belong to or is a part of the Python programming language and coded into Python itself. So, the Python data storage data types you will learn in this part of the video course are the Python set, the Python tuple, the Python dictionary, and the Python list. In addition to these native data storage types or abstractions, many Python programs and libraries use non-native data storage abstractions. For example, in video courses about data handling, the Pandas library is often used, and it uses Pandas data frames, objects similar to Excel spreadsheets on steroids, to store and handle data supported by Python programming, and most commonly Python dictionaries and lists. So, in this mini course, we will talk about the Python native set, which is used in some algorithms and sometimes used for set math. We will talk about the Python tuple, which is a very common return type from Python functions and libraries. In some aspects, a default return type for multi-object returns in the Python programming language. Tuples are fixed and therefore fast, properties sometimes used as a speed enhancement. We will talk about Python dictionaries, which are a dictionary data type with ensured uniqueness of dictionary keys, making this abstraction very useful for some key lookup tasks. And we will talk about the Python list, which is a highly versatile, general, and changeable object, and as such very useful, powerful, and almost necessary for effective data handling. In the next part of this mini course, we will talk about the Python set and data storage abstraction, which is one of the most fundamental of Python's native data storage abstractions. And we aim at going a bit deeper than most other video courses, and this mini course is therefore suitable for both beginner Python users and people who want to learn tools that will enhance their coding, data science, data analysis, data handling, or machine learning capabilities. We look forward to have you continue to watch this mini course. Hello and welcome to this video about Python sets for data handling. In this video, you will learn about the Python set, which is a Python native data storage abstraction, or you could say a native Python data structure. The set provides you with the option to economically store unique labels or objects. These labels or objects will be fixed and are not intended to be changed while the objects are contained within the set. Sets have two main uses within data handling. One as a storage type for unique labels or objects, making the data storage requirements smaller for certain data storage systems. The other use is within algorithms that operate on, for example, data forms with unknown but unique properties, such as unique column or row labels in a spreadsheet. Then the set is a useful holder for column or row labels, or you could say object identities or names. Python's native set class has developed a lot over new Python versions, and more development is expected in the future. So let's take a more detailed look at the set. And the set is a Python data storage type for an unordered collection of unique objects that cannot be changed as long as the object is within the set. This means that set is a collection of unique objects and that it contains objects that can only be one of a kind, and that the stored objects cannot be changed as long as they are contained inside the set. The properties of sets are that sets are mutable, and that is that new elements can be added after the set has been created or defined. So this means that you can increase the size of the set and add new items to the set whenever you want. There is one exception to this, and that is that the set can be made immutable through Python's frozen set function, and that means that the set will be effectively frozen and cannot be changed after the use of Python's frozen set function. Sets are unordered and don't have index numbers inside the set. And this means that there is no function to sort the set's contents using the set itself, and that there is no formalized index function included with the set. The order of the contents inside a set may therefore appear as being random or arbitrary without being either random or arbitrary. Python sets allow for math operations such as the union, intersection, difference, and symmetric difference between two or more Python sets. And this means that it is possible to compute union, intersection, difference, and symmetric differences between two or several Python sets. And this property can be used as one of the many ways to find duplicate objects or similar uses of these math operations. So, the main use of Python set equivalents in older administrative data science code was to economically store labels connected to integer codes. The stored set codes was mainly geographical localities or telephone numbers, postal area codes, state codes, localities, or whatever type of codes you or anyone wanted to use. And this made similar constructions to Python sets very useful in the early era of computing, when RAM memory and storage space was expensive and very constrained, whereas current application storage space often, but not always, grows faster than the need for storage space, for example in cloud computing. At the most basic design level, this design resulted in that 8, 16, or 32-bit integers could replace a string or a number of strings for a data entry. And this was very economical. Currently, however, coders often store entire strings in each data entry, which creates a lot of data handling work due to many different strings representing the same object type, or completely unique string entries may be created, such as, for example, a non-existing unique street address that the post will be delivered to without complaint due to the human capacity of converting the non-existing address to an existing address. Another modern option is the year 2K dictionary object, which can do the same trick by using the integer as a key and the string as a value, while not needing any lookup code attached between the key and the value. The modern dictionary could thus be viewed as a double set or as a set plus a list for every set entry, although it is alleged that Python sets in some versions of Python are implemented using dictionaries. So, Python sets are used in some data science and machine learning algorithms where sets may be used as containers for column or row identities. So you can have sets which are unprocessed and sets or other storage abstractions which are processed. And when an object has been processed, you move it from the unprocessed set into the processed set or other storage abstractions. Similarly, you can have a set of features or columns or rows can be included in the model, and they can be excluded from the model. The columns, features, observations, entries, or rows can be struck from being included in the model or investigated to be included in the model. The math operations that Python currently allows on Python sets can be used to further extend this type of use of Python sets. All right, let's talk a little about how Python creates a set. And Python creates a set by using the curly brackets enclosing objects or items within the set. And another way of creating a set is by using the set constructor. So right, now we're going to make a number of coding examples to show some of the Python set's properties. So start up your code editors because we're going to type some code. All right, having started our code editors, we will start to type some code. And we will begin by describing the code we will type. So we type Python set. And we will start by creating a set named fruits with string fruits objects inside the set. So we type create a set named fruits with named fruit objects strings inside the set. And we will use the curly brackets, and we will use strings as fruit objects. And we will close the curly brackets, and we will print the fruits. And we can print the type of the fruits. So let's run this code. And as you can see, the Python set only accepts unique objects. So here we can see that we have 2 bananas and 1 banana disappeared because Python doesn't accept duplicates in a set. And similar with the apple. So let's type all duplicates of fruits were automatically removed from the set, and only one instance of each fruit object remains. And we can type the objects appear to be random or unordered, but are they random? And we can test this by simply cut and pasting this code. We create a new set of fruits. And what is of interest is this order here. Or you could say this unordered collection of string fruit objects. So let's run this code. And we can conclude that the Python set is unordered, but not random. There is an order to the set under the hood. So all right, now we have shown that the set is unordered, but not random. So now we know that there is an order under the hood, but we cannot see what type of order is implemented currently. And this means that we have to accept that the set is unordered. So all right, let's test some set functions. So let's test to add more fruits to the fruit set with the add function. So we can type add more fruits to the fruit set with the add function. So we type fruits, add a lemon, and we type fruits, add a banana. And we can print the fruits. And this will show that duplicates are removed and that new items are, you could say, added. So here we will display the mutable concept of the set. So let's run this code. And here we can see that the banana was removed as it was already included in the set. But the lemon was added because there was no lemon inside the set. And we can try to add multiple items or objects to a set using the update function. So we type add multiple objects or items to a set with the update function. Or you could say method. So we type fruits, update, and now we can use a list of fruits. So we have a pear, we have a citrus, and we have a peach. And we close the list like this. And we type print fruits. So let's run this code. So here we can see that the pear was added, that the citrus was added, but we already have a peach in this set. So the peach was not added but removed. So we can type the new fruits were added and the duplicates were removed. And now we'll try to copy the set. So we type sets can be copied using the copy function. So we type fruitage equals fruits dot copy. And this will create a shallow copy. So we will print fruitage So let's run this code. And we have a copy of the fruit set, and that copy is named fruitage. And now we'll remove objects from the set using the remove function, and we will test the fruitage copy a little. So let's type remove objects from a set using the remove function. Or you could say method. So we type fruitage remove, and we can remove the citrus. So print fruitage and we print test fruits. So here we just print a string and we print the fruits. So let's run this code. And we can conclude that citrus was indeed removed. And we can type that a shallow copy is sufficient for this use. And if it is not, then the alternative is a deep copy. So let's try various ways to reset, clear, or delete a set. So we will clear a set from its object using the clear function. Or you could say method. So we type fruits, clear, and we print the fruits. So let's run this code. And we can see that the fruits set is empty. So here we have a set which is empty. So let's test to delete a set with the delete function. So we type delete a set with the delete function. So we type delete fruits, and we will print the fruits. And we can say that this code will throw an error if fruits have been deleted. So let's run this code. And here we can see that the set is indeed deleted. And this error proves that there is no set or object named fruits. And now we'll loop through the fruitage set. So let's type loop through a set using a for loop and print the contents. So we type for fruits in fruitage, print fruits. And let's run this code. And here we can see that the set is iterable and that we can loop through its contents. And now we'll test some set math operations and show the current way to move an object inside a set into another set. So let's type create an empty basket set and put some fruits in it using set math operations and a mover set. So we begin by creating a mover set like this, and we add an apple to it. We can add a peach, and we can add a banana. And we close the set, and we print the fruitage to display the content of the fruitage set. And we type basket equals mover set intersection with fruitage. And we type fruitage difference update basket. And we can type that future Python sets may have a one-liner method for moving an object between two sets. And we will print the basket and we will print the fruitage. And we make a little change there. So let's run this code. So here we can see the original fruitage set, and here we can see the new basket set. And we can see the resulting fruitage set after we have moved the peach, the apple, and the banana into the basket set. So this is what we can see from this code. The apple, peach, and the banana was moved from the fruitage set to the basket set with a mat operation method. And this method has the advantage that it works with most objects and not just basic strings, ints, and floats. So even if you have your own designed, you could say giraffe or elephant or donkey object, and you have put it into a set, this set mat operation will work. Whereas some other methods may be constrained to Python native types. And as we stated or typed, in the future, a more proper move object method will likely be designed because this set has been developed at ultra speed since Python 1 and 2, and we expect this development to continue. So right, in this video you learned a lot about sets and how sets can be used for data handling. In the next video, we will teach you more, and we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We are excited to have you here, and in this video lecture you will learn about the tuple, which is a Python native data storage abstraction, or you could say native Python data structure. The tuple provides us with the option to economically store labels and objects that are fixed and not intended to be changed. As tuples are defined to not be changed, their properties are easy to predict, and therefore tuples are faster than any other Python data structures. Tuples are important to know for data handling purposes, as tuples are used in a lot of older data science and machine learning applications, programs, libraries, and code, plus are a very common return type for Python libraries. Let's talk some about Python tuples in detail. So now we're going to talk about Python tuples. And tuples are considered to be another type of Python set, mainly used in older Python data science code as a tool for optimizations, speed enhancements for code, and to some degree as a still preferred return object for some important libraries functions. In this video, we include a deep dive into tuples mainly because a lot of machine learning code, libraries, and in particular older machine learning code may use tuples for optimizations and other tuple properties. And this increases the chance, or rather makes it almost certain, that any data scientist or machine learning engineer will encounter tuples in their code or libraries sooner or later. The properties of the Python tuples are that the contents of a tuple are ordered, or you could say indexable, and unchangeable, or as you could say immutable. This means that the new items cannot be added to a tuple once it is created, and that the object items inside the tuple cannot be changed or replaced except through a process of conversion, where the tuple is changed or copied into another object type, and the items are replaced, and the result is changed again into a new tuple, possibly with the same name. If the item objects inside a tuple is of a changeable type and must be changed, they need to be copied in a similar process, changed, and converted back to a tuple object. Structurally, tuples can be considered to be sequences of object items or as unchangeable lists, or you could say arrays with different properties and capabilities than Python's native lists. And we can say that Python tuples are fast and predictable due to these properties. And Python creates a tuple through the use of parentheses enclosing items within the tuple. And you can see some example code on the screen, but now it is time to type some code. So let's open your code editors. And we will open the Jupyter Labs notebook and type some tuple code. All right, having started our code editors, we will start to type some tuple code. So we will type Python tuples. And we will begin by creating some tuples. And here we will show some issues with the tuple. So the first tuple we will create will not be a tuple at all, but something that looks like a tuple but doesn't function as a tuple and is created as a different object than a tuple. So we will type tuple1 equals 1, 2, 3, 4, 5. And we can say that this will return an error if a tuple is expected. So we can print this not a tuple, and we can print the type of this not a tuple. So let's run this code. And here we can see that we created an integer and not a tuple with this code. So now we'll change this code to proper tuple code. So we'll type tuple1 equals 1, 2, 3, 4, 5 and 1. And we will print this tuple, and we will print the type of this tuple. So let's run this code. And here we can see that we have created a proper tuple. Now we will create more tuples. So we will create tuple2 and we will set it to 2 strings, hello and world. We will create tuple 3, and we will set it to a string, hello, and we will create some integers and a world string. And this displays that tuples can hold arbitrary Python objects. And we will create tuple 4, and we will let it contain some integers and some floats. So we have created a tuple with some integers and some floats. And now we will type some code that shows that we can add these tuples together, for example, within a print instruction. We can print tuple 2 plus tuple 3, and we can print tuple 1 plus tuple 4. So let's run this code. And here we can see that we added tuple 2 to tuple 3, and we added tuple 1 to tuple 4. And now we will create some nested tuples. And nested tuples are tuples within tuples. We type create nested tuples, or you could say tuples within tuples. And we can also say that we can create tuples including, for example, named and declared integers, floats, etc. We type float 1 equals 3.91, integer 1 equals 9, and we can set tuple 5 to be equal to float 1, integer 1, and a nested tuple hello world. And we can print tuple 5. So let's run this code. And here we can see that the values of these declared floats and integers were printed, plus the nested tuple. And here we can take a look at how to access the elements of a complex tuple such as tuple 5. So we can begin to type print tuple 5, and the first element of it. And we can continue with this notation. And we can print every element in the tuple. And we can show you how to access the nested tuple. So this line will access the second element of the nested tuple. So let's run this code. And here we can see that the first element, float 1, is 3.91. The second element is integer 1, it is 9. The third element, which we point at with E2, is the nested tuple hello world. And when we add another bracket like this, we can access the second element of the nested tuple. And in this case, this is the string world. And as you can see, this is very useful when it comes to handling tuples. And we can build some more on this knowledge. So we can say that we can access the contents of a tuple by referring to the order of the items inside the tuple, indexed from 0 to the number of items minus 1. So for example, we can take tuple 3 and refer to the first element, and we can print tuple 3 and refer to the third element. And here we have tuple 3's first element and the last element, or the third element. So let's run this code. And here we can see hello and world. Now we will use some advanced functions on our tuples. And we can say that if you feel that this part of the video lecture is tough, complete the Python for data handling section or video course and return to this part afterwards. If this part still feels tough, repeat the course once more and return. And you will feel that with this repetition, this code and this complexity has suddenly become very easy for you, and you will understand this code easily, and everything will be clear with some repetition. So, all right. Let's begin with some native functions which are pre-programmed into Python. And we will begin with the length function. Or you could say method for tuples. So we type print the length of, for example, tuple 2. And we can print the length of tuple 4. And what this function returns is an integer, which will tell us how many items are included inside these referred tuples. So let's run this code. And the printed numbers are 2 and 4. The number of items inside the referred tuples. And we can access the content of tuples as ranges within the tuples using a particular operator. So we can type tuples can be accessed as ranges using the operator type, for example, tuple 4. And this code should access the first two elements of tuple 4. And these are 1 and 4. So let's run this code. And here we can see that we have 1 and 4. And we can use loops to loop tuples. We can type 4 items in tuple 4, print items. So let's run this code. And here we can see that for each and every item in tuple 4, we printed that item. So we have 1, 4, 2.73, and 3.1. We can use the index positions of a tuple and use the length function and loops. We can type for position in a range of the length of, for example, tuple 3. We can print the position plus like this. And pos will be a counter variable between 0 and the range of the length of tuple 3. So the first instruction here will print that integer number, and the second here will print the content of tuple 3 at that position. So let's run this code. And here we can see that at position 0 we have the string hello. At position 1 we have the integer 1, 2, 3, 4, 5. And at the position 2 we have the string world. And now we'll take a look at tuple returns from functions and library functions. And we can say that these returns is one of the main occurrences of tuples in current Python libraries. And the unchangeable property of tuples is one of the main reasons for using tuples as a return item from a function or library. And the secondary reason is the tuples design and predictable size address location, which makes these returns very easy to handle in RAM memory. So we will type tuple returns from functions and library functions is one of the main occurrences of tuples in current Python libraries. Two reasons. unchangeability, and design and predictable size, address, location. Let's take a look at tuple unpacking. Because these tuples, when you receive them as returns, will be, you could say, packed as tuples. And therefore, we will take a look at unpacking these tuples, which is about making proper variables from a tuple. Something which often will be necessary when you consider returns from libraries. So we can type, for example, float 2, integer 2, tuple 6 equals tuple 5. And we can print string float 2 plus a white space plus string integer 2 plus white space plus string tuple 6. Here we will take tuple 5 and unpack it into float 2, integer 2, and tuple 6. And tuple 5 is this nested tuple, which has a float, an integer, and a tuple. So let's run this code. And here you can see that we have unpacked it into the float, an integer, and this tuple. And what we will do now is that we will continue the unpacking further. So we will create string 1, string 2 from tuple 6. And we will print string 1 plus white space plus string 2. And as we have strings, we have no need to cast strings into strings. So let's run this code. And here we can see that we printed the string hello, a white space, and the string world. So here we can see that we have completed the unpacking of these already existing tuples. So what we'll do now is that we will show a custom statistics function with multiple returns. And we will say that Python, as a standard, when you have multiple returns, will always, in its functions, return the returns as a tuple. So this is a pre-programmed standard. So right, let's throw a custom short statistics function with multiple returns. We type define descriptive stats from data, and we can import a library. So we type from statistics import mean, median, and standard deviations. So what we do now is that we make a sort of proper import from the statistics library, because we will borrow some functionality for this custom statistics function in order to display these multiple returns and how they are unpacked. So we type average equals mean data. We type med equals median data. We type standard deviation equals standard deviation of the data. And we return the average, the med, and the standard deviation. What we will do now is that we will print the return of this function. So we will call the function, and we will give it tuple 4. So let's run this code. And here we can see that the function took the data in tuple 4, which we served it, and it returned the average of the data, the median of the data, and the standard deviation of the data. And it returned it as a tuple. So what we will do now is that we will unpack the tuple return. We will type mean, med, standard deviation equals descriptive statistics of tuple 4. And we will print the mean plus white space plus the median plus some white space plus the standard deviation. So let's run this code. And here we can see that the return tuple has been properly unpacked. All right, now we have learned some deep, practical, and very useful knowledge on how to use tuples. And in the next video, we will teach you even more. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. In this video lecture, you will learn about the dictionary, which is a Python native data storage abstraction, or you could say Python data storage abstraction. The Python dictionary provides speed, data key pairings, and ensured uniqueness of dictionary keys. When using Python and/or Pandas for data handling, dictionaries are often used to create mappings for name changes, mappings for transformations, or mappings to create input for Pandas data frames. Dictionaries are also frequently used as an effective tool to create mappings between data items or values and translations, such as colors in plots and graphics, or to create labels for classes. Dictionaries are a very useful tool to know for data handling purposes. Now we'll talk about the Python dictionary data type, and the dictionary is a collection that requires data to be stored in key plus value pairs. And the dictionary is a quite modern addition to current programming languages and is mainly used for speed and the ensured uniqueness of keys within collections or data sources for data science analysis or machine learning tasks. The enforced uniqueness of keys is very useful for data security in data handling tasks and may, for example, by design, prevent multiple values where uniqueness is required or wanted. The properties of the Python dictionary are that dictionary items, which are key plus value pairs, are ordered by the insertion order, changeable, and that dictionaries don't allow duplicates of dictionary keys. A dictionary key is restricted to strings, numbers, or tuples with arbitrary values, as long as the values are immutable with some restrictions to the object types. Dictionaries are indexed by their keys and may have any current Python object as data values, including other collections or even Python dictionaries. And on the screen, you can see an example piece of code that shows some Python dictionary code and is a fictitious mail catalog where a person's fictitious name is used as a string key and a fictitious mail address is used as string data or string values. Now we'll type some Python dictionary code. So let's start up your code editors. All right, having started our code editors, we will type some Python dictionary code. And we will start by typing the string object mail catalog code example from the PowerPoint. So we will begin to type Python dictionary. And we will create a Python dictionary with 3 key value pairs consisting of a string key and a value string. We type mailcat equals Joe for the first key and joe.joe@gmail.com. We add the second key as an and we add the third key, Lisa, and we will print our mailcat and we will print the type of our mailcat. So let's run this code. And here we can see that we have the class dictionary, and we can see that we have our dictionary with 3 key value entries. And the first thing we'll do is that we will add a new instance Mohammed to the dictionary. We type mailcat Mohammed equals mohammed@gmail.com. And we can print the mail cat. So let's run this code. And here we can see that we have added a new instance of key value pairs to the dictionary. So here we have the key Mohammed and we have the string value of this Gmail address. So here we can see that we can add new instances using assignment. And we can say that a dictionary is created with a name, the equality sign, and 2 curly brackets. We have the name of the dictionary equals something within these brackets. What we'll do now is that we will add an integer key string instance to the mail cat to show its versatility. We type mailcat 5 equals, this is a string with an integer key. And we can print the mailcat. So let's run this code. And here we can see that we have added a key, integer 5, and a string. This is a string with an integer key. Now we will show some ways to address and print the dictionary keys and items. We print mailcat.keys. We can print mailcat.values. And we can print mailcat.items. And this will print the dictionary's key value pairs as a list of tuples. So let's run this code. And here we can see that we have the dictionary keys printed. So here we have the keys as a list. Here we have the values. And here we have keys and values when we refer to the dictionary's items. And we have some more methods, or you could say functions. We can print, for example, mailcat.lisa, which refers to the key Lisa. And this will print the value of the Lisa key value pair. And we can print mailcat 5 and this will print the value for the key integer 5. And we can also print mailcat.get Lisa. And this will return the value for the key in the dictionary. And if not found, it will return a default value. And here we can say that it is important that you note that key names must be correctly specified with upper and lower case characters wherever appropriate. And this is quite different from mail addresses because mail addresses tend to always be lower characters. So you can type them with upper characters, but when you use them, they will always be interpreted with lower characters. So let's run this code. And here we can see that the value for Lisa is lisa@gmx.com. The value for 5 is this is a list with an integer key. And the return for get Lisa is lisa@gmx.com. All right, now we'll talk some about changing the value for a key in the dictionary. And this is done with assignment. So we type to change a value in the dictionary, assignment can be used. For example, we can type mailcat Joe equals Joe to Joe 2 at gmail.com. And we can print our mailcat. So let's run this code. And here you can see that Joe.Joe was changed to Joe2.Joe2. And for example, if we want to delete a key value pair or an item, type delete mailcat 5 and we can print our mailcat. So let's run this code. And here you can see that the key 5 with its value has been removed from our dictionary. All right, now we're going to type some advanced dictionary functions. And we must say that if these functions feel complex or advanced or even hard to grasp right now, we recommend that you return to this video after completing this entire video and Python section. So when you have completed this section, you return to this video lecture, and if these functions still feel complex, you can try the Pandas section or course and return again. And all will be clear with some practice and exercise. And as you know, practice and exercise makes the master. All right, we will start with the length function, which returns an integer describing the number of items or elements in a dictionary. We can type print the length of the male cat. So let's run this code. And here we can see that we had the integer number 4 returned, and we have 1, 2, 3, and 4 key value instances in our dictionary. And we can use the string function to cast, or you could say create a string of the entire dictionary. And we can say that this may be useful in some text mining applications. So let's type print string male cat. And we can print the type of the string of the male cat. And we can say that this will return a string within curly brackets. So let's run this code. And here we can see that we have the class string for this object, and that we have a string within curly brackets. And now we'll test some loops on our dictionary, and we will primarily use for loops. We can type that this for loop iterates through all the keys in a dictionary, and the function will print each key on a new line. We type for M in mailcat, print M. And here we can say that the default for the dictionary when we type print M is the key. So let's run this code. And here we can see that we have our 4 keys printed, each on a new line. And we can do this explicitly. We type 4k in mailcat.keys. Print k. So let's run this code. So here we can see that this instruction, in principle, we could say executed the same work, but it actually didn't do exactly the same work, but it created exactly the same result for this dictionary. And we can say that we can print the values in the same way. We can print for we in mailcat.values. Print we for value. So let's run this code. And here we can see that we printed the values of our dictionary. And now we will type a loop that iterates through all key value pairs in our dictionary and prints each key value on a new line. We type for key and value in mailcat.items. Print key and value. So let's run this code. And here we can see that it printed the key and the value, the key and the value. So now we'll talk some about nested dictionaries. And these are very complex constructions that exists nowadays because programmers tend to enjoy to create advanced databases and advanced object-oriented constructions. And what you sometimes end up with is dictionaries of the nested type, where, for example, one dictionary may hold a number of, or even a hierarchy of nested dictionaries. And this can be very efficient when you code it to store data, because you can create a lot of nested dictionaries, which can handle, for example, sparse data matrices. But when you extract this data from the database, if the programmer hasn't taken account and created functions for all possible scenarios, which they never do, then you could have a data handling issue with these nested dictionaries. And these issues can take many different dimensions. One is that you can get a matrix of data which is a lot more sparse than it should be. And the other is that you get the nested data in a nested fashion, and that you will have to execute very advanced data handling in order to actually use the data. And for most university educated programmers and data analysts, there is a huge gap between the requirements to properly analyze these databases and their current capabilities to actually do so. So here we will teach you very valuable information. So all right, let's begin. Nested dictionaries. And we will create a dictionary inside our current dictionary. So we type mailcat, special mail, equals a dictionary, and the first key is Rolf. Rolf and we create a second key, and we close the dictionary, and we can print our mailcat, and we will cast it as a string. And we can say that this is a nested dictionary with a complex multi-type structure. So let's run this code. And here we can see that our nested dictionary has been added to our dictionary. So here we can say that we have a dictionary with a double structure. So you have an ordinary dictionary and you have a nested dictionary. And this creates a complex object-oriented data structure. And we can say that currently there is no inbuilt, easy accessible Python function to handle these multi-type structures. And this means that you will have to write all the code yourself to handle them. And the first thing we will do is that we will type a for loop using the direct known address of a part of the multi-type structure we type for key and value in mailcat specmail. We can type name and address equals key and value. And we can print the name and the address. So right, this code will iterate only over a small part of our dictionary, and we will only iterate over the spec-mail part of the dictionary. And this is what we specify here in the first part of the for loop. And the second part is that we will only iterate over the items. And this makes sure that we will only iterate over key and values. And in the second part of the for loop, we will unpack the key and the value to name and address, and we'll print the name and address. So let's run this code. And here you can see that you have the key and the value of this nested dictionary. So what you can do with this for loop is that you can extract this information and you can put it into a new dictionary and you can add these dictionaries together. For example, manually or automatically. And this is a bit interesting, so we can continue to type and we can use keys and direct known addresses on exactly defined part of the multi-type structure. And we can say that this has many different solutions. So there probably are 10 or 20 different ways to type this solution. So we can print the list, mailcat, spec mail, keys, and here we can put a 0 and we close the print instruction. And we can print mailcat, spec mail, roles. And what the first line does is that it takes the mailcat, limits it to the nested dictionary and its keys. And it takes this part of the dictionary or the output or return of the keys function, cast it as a list, and selects the first element of that list. And it prints it. And this will be roles. And this other instruction does the same thing, but it points directly at Rolf. And this Rolf will return the value, which is Rolf's mail address. So let's run this code. And here we can see that we have the key and we have the value. And we can extend this to automation. So we can type that here we have a not so Pythonic automation variant, which makes it possible to list and address key value pairs using list position notation. And when we say that the code we will type now is not so Pythonic, means that it is complex and it is overbearing and it uses several casts or conversions to achieve a very useful result. We can type print list mailcat. We point at the spec mail. And we will only use the keys. And the second thing we will do is that we will print the mailcat spec mail. This. We can take this code and we can simply cut and paste it. And we can change zeros to ones. Because as you remember, in this nested dictionary, we had 2 entries and not 1. So let's run this code. And here you can see that we have the key and the value and the key and the value. And this is very useful because now we can address and point at each element and we can create almost arbitrary solutions to collect all information in these nested dictionaries. And the only thing which is bad with this code is that it is non-Pythonic. And this means that it is complex and that it uses a large number of steps to achieve its results and therefore becomes hard to type, hard to read, and a bit tough to understand. Yet this code is very useful. And now we'll show a Pythonic way to automate the flattening of the mailcat dictionary to a standard dictionary. And we will delete the nested dictionary. So now we'll show you how to handle exactly this type of nested dictionary and turn it into a you could say unitype or standard dictionary, which you can analyze and use with standard data analysis tools and all such things. So let's type use a Pythonic automation variant to flatten the Mailcat dictionary to a standard dictionary and delete the nested dictionary. So we type for K and V for value in Mailcat spec mail items Mailcat K equals value. And we will delete Mailcat spec mail. And we'll print the resulting Mailcat. So let's run this code. And here we can see that we have a ordinary Python dictionary where the keys and the values of the nested dictionary has been assigned to the standard dictionary. And as a final part of this, you could say, transformation, the nested dictionary was deleted. So right, now we will talk some about how to clear or delete a dictionary. And the first thing we will do is that we will use the clear instruction to delete all elements or items in a dictionary. We can print the Mailcat and we will see what remains. So let's run this code. And here we can see that all we have is an empty dictionary, which is represented here by two, you could say, brackets. And now we will delete Mailcat. And we can try to print Mailcat after deleting it. And this will return an error because there is no Mailcat anymore. So let's run this code. And here we can see that the delete instruction removed the Mailcat from memory. And therefore the name Mailcat is no longer defined. So right, in this video lecture you learned how to use Python dictionaries and you learned a lot of useful and advanced knowledge about dictionaries. And in the next video lecture we'll teach you even more. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. In this video lecture you will learn about the Python list, which is a Python native data storage abstraction. The list provides Python users with a data storage solution which is versatile, extendable, updatable, changeable, general, and a one for almost all situations solution for most types of data storage. Some Python users even consider the lists or modified lists to be the solution for every or any and all data storage situations. The list is a very common data storage tool, both as a standalone object or as an object inside other objects. The Python list is a very useful tool to know for data handling purposes. Now we're going to talk some in detail about the Python list data type. And for data science, data analysis, and machine learning purposes, the Python list data type is the most useful, versatile, and general data storage type available. The list data type is a container for items or objects that are ordered, changeable, and allows duplicate items or values. In practice, this means that with a Python list, we can update, delete, remove, or add objects to the list, or even add copies of existing objects in a list to the same or another list after the list has been created. This is a very useful property of the list, and the list can also accept any type of Python objects, so a list can contain integers, strings, arbitrary user-created objects, tuples, sets, other lists, or whatever object you want to have in the list at the same time. The object types don't matter to the list object. And this means that the Python list is so general that the stored objects don't need to be of the same type. And this property of the Python list has consequences as compared to lists in some other languages. And this consequently means that when you use lists in practice, in applications, you must control whatever object your program put into the list, and both control the objects themselves and the knowledge of the object types. Or if you don't have that knowledge or that level of control, you must check what type of object you get from the list when you ask for the object, or an object at a position in the list. Because when you ask a Python list for its contents, you will receive the contents. And sometimes it may be an integer, and sometimes it may be a string, and sometimes it may be a float, or an arbitrary user-created object. And we can say that many users of Python lists for applications with uncontrolled data input or content recommend the type and value checking both when the object is added to the list and when the object is read or extracted from the list. Another way to obtain similar control levels is to recreate all input objects to a predefined coded object type before adding the new object to the list. There are, for example, advanced instances where the object type is unknown, not defined by Python, or not defined at all, or in some extreme cases defines itself as a Python object of the native type without being so. So it may quack as a duck, but not being a duck. And this type checking may be particularly true for advanced and uncontrolled input or measurement situations, but is uncommon for controlled input or data situations. So when you have your data set in a comma-separated file and everything is proper, and you have these textbooks data set, this may never be a problem. But when you use measurement systems in nature, or on humans or whatever, you may get these input or output troubles. And the worst data usually comes from the internet. because when you have some random users sending you data on the internet, either through a web interface or something, you don't really know what sort of data you will actually get. And this can be valuable knowledge for real-time data analysis within internet applications, for example. So, right, this description shows the most important properties of the list: the list's flexibility and the need to control the list and its objects either at input time or at output time, or perhaps at both the input time and the output time. So the technical properties of the list are that list items are indexed with integer numbers, and that the first item in a list always has the index number 0, the second 1, the third 2, and so on. Lists has the advantage that we can address a position in the list by referring to an integer number. And Python creates lists through items separated by commas within brackets. And now we're going to take a look at some example code. So start up your code editors, because we're going to type some Python list code. All right, having started our code editors, we will type some Python list code. And we will start to type Python list. And we will create a first list. We type list1 equals integer 7, 4, 3, 9, and the string bananas. We can print the type of list1, and we can print list1. So let's run this code. And here we can see that we have a list. And we can see that this list consists of the integers 7, 4, 3, 9, and the string bananas. We can show how to address list objects using the object's position inside the list. We can type print string list1 3 plus string list 1 plus some white space plus string list1 4. And we can type that string list index instructs Python to print the content at position index as a string. And we can say that this is one way to control the output from a list. And this is a flawed way to control the output from a list, but it is effective and it will work for most native Python objects. So let's run this code. And here we can see that we have the output 93 bananas. Now we will operate on list objects using the list notation. We will print type of list 1. And we will print the type of the string of list 1 at position 3. So let's run this code. And here we can see that the object at position 3 is an integer. And here we can see that we have cast this integer as a string. And we can continue and we can say that a list object content may be changed by assignment. We can type list2 equals 2. And we can print list1. And we can say that this will print 7, 4, 2, 9 bananas. So let's run this code. And we can say that new objects can be added to a list with the append method. We can type that we want to append apples. And we can print list1. So let's run this code. And here we can see that we have added apples to the last part of this list. And we can say that we can remove objects from a list using the delete statement or the remove method. We can type delete list1 element 4. And we can print list1 and this will remove the bananas. So let's run this code. And here you can see that list element 4 was removed from the list. And we can also use the remove instruction. So we can type list1 remove apples. And we can print list1. And this will remove the apples. So let's run this code. And here we can see that the apples has been removed. And we can say that Python lists can be added together using inter alia, the plus operator, or the extend or append methods. So now we will create a list 2 and a list 3. So we type list 2 equals 1, 4, 5, 6, and 8. And we can create list 3 as list 1 plus list 2. And we can print list 3. So let's run this code. And here we can see that list 1 and list 2 has been added together. And we can use the append method, so we can type list 1 append list 3. And we can print list 1. So let's run this code. And here we can see that list 1 has had list 3 appended at the 4th position as a nested list. And we can type list 3 extend list 2. And we can print list 3. So let's run this code. Here we can see that we have list 3 extended by list 2. And now we will show some properties of the list. For example, how you count the number of objects inside the list, or you could say the number of active object positions. So we will print the length of list 3. And we will print the length of list 1. So let's run this code. And here we can see that list 3 has indeed 14 positions. 4, 6, 8, 10, 12, and 14. And we can see that list 1 only has 5 positions. So here we have the first 4, and this entire list counts as 1 position. So how many elements you get from the length instruction depends on whether you have list brackets for this list at a position, or if you, for example, extends with the content instead of the entire list. So using the append or extend instruction results in different results. And this is something to keep in mind and something to think about when considering lists, and in particular lists of lists. But let's save the list of lists or multidimensional lists for last. So now we will learn to sort list 3. So we will print list 3, and we will sort this list. And we will print list 3 after it has been sorted. So let's run this code. And here we can see list 3 unsorted, and we can see list 3 sorted. And this sort instruction will sort these integers based on the value of the integers in the list. And you can sort them both ascending and descending. And sorting lists are often important within data handling. So right, now we'll address ranges of the list. We can print list 1 to 4. And this will give us in the case of list 3, 1, 2, and 4. Like this. And we can print list 3. And this will give us 1, 1, 2. Everything to the left of element 3, which is 4 in this case. And we can print list 3. And this will give us 8 and 9. What we say here is that everything to the right of element 12, and you know that it is 14 elements here. So this is 14, 13, and this is number 12. So all right, let's run this code. And here we can see that we have a list consisting of 1, 2, and 4, 1, 1, and 2, and 8, and 9. And as you can see, this is very useful because here we can point at the number of positions in a list. We can print them, or we can make operations on them. And we will look a bit more at this when we look at multidimensional or list of lists in the final advanced section of this video. Now we will take a look at how to loop a list using for loops. And this is very simple. So we just type for x in list 3, print x. And let's run this code. And here you can see 1, 1, 2, 4, 8, 9. So here we have looped the list and we have printed the list. And now we'll take a look at moving objects from one list to another list. And this is often very important both in data handling and in, for example, algorithms. So you want to move, for example, one object after operation to another list, and so on. We can begin by printing list 1, and we can print list 3. And we can take list 3 and we can append list 1, pop 1. And we will print list 1 and we will print list 3. So let's run this code. And here we can see that from list 1, we have the object at position 1, which is a 4. And that has been moved to the last position of list 3. So this 4 has been moved here. And here we can see that the 4 has disappeared. And we can see that the 4 has been added to this list. And we can move objects from one list to a specified position in another list. We can type print list 1 and we can print list 3, and from list 3 we can insert at position 2 list 1, the first item. And we can print list 1 after operation, and we can print list 3 after the operation. So let's run this code. And here we can see that object 7 has been injected into position 2 on list 3. And we can also see that integer 7 has disappeared from list 1. So right, now we're going to look at advanced list functions and such things. So if you feel that this part of the video lecture becomes a bit advanced, just continue to the next video and return to this video later. For example, when you have made one pass through this section on Python, you can return here, and for every repetition of this video, you will grow better and more competent. And this should be quite simple, even if you are a rookie after 1 or 2 passes. So right, now we will take a look at type checking using the type and is instance methods, or you could say functions. And we can say that object type checking may be straightforward when all data is molded into a Python compatible form or a Python form. And we can say that this is not always true. For example, when sent unknown data over the internet, or if you're using analog or digital measurement systems. And we can say that type checking can very quickly become very advanced. So what we will do now is that we will show some basic functions for type checking, assuming a list of integers, or the intention to have a, you could say, a list of integers. We can type string test1 equals 1 and string test2 equals 1. So here we have 2 named strings. One is a string and one is an integer. And we will append them at list 3. And we will print list 3. So let's run this code. And here we can see that we have a list of integers, but that we have a string concealed as an integer inside this list. And in this version of this video, we will not add a bug to this type of type checking, but we want to make it known, or make you understand that type checking is very advanced and that it can fail even when it looks foolproof and you have covered all possible types of objects. And this is in particular true for internet data, but also happens with measurement data. So right, let's type for x in list 3 if type x is not int, print not integer. Else print integer. And we can type for x in list 3 if instance of x is an int, print integer. Else print not integer. And here we will add some white space. So let's run this code. And here we can see that in both these cases, both these methods managed to identify this string as a not integer. And this is a textbook way of showing type checking. And when you add custom objects or, for example, custom objects that can overlap with Python's native classes, such as, for example, ints and strings, then this quickly becomes very advanced. So right, now we'll take a look at multi-level lists. Also called list of lists or multidimensional lists. So what we'll do now is that we will create a list 4, which is equal to 1, 3, and 5. We will make a list 5, which is equal to 2, 4, and 6. And we'll make a list 6, which is equal to 3, 5, and 7. And we will make a list 7, which is equal to list 4, list 5, and list 6. And we will play around a little with these lists. So we will print list 7. And let's run this code. And here we can see that the list 7 at its first position has this list. At the second position, it has list 5. and so on. So what we'll do now is that we will show how to address multi-level lists. So we will print list 7, first element, and we will use the brackets to print the second element of this list. So let's run this code. And here we can see that first we identified this first list, and the second number inside the bracket identified this object inside the nested list. Now we'll play some more. So we will type list 4, extend list 5. And we'll print list 7. And this result may shock you a little bit. So let's run this code. And here you can see that list 7 and list 4 are nested objects and not separate objects. And persons who have experienced with older static programming languages might find this a bit surprising, because they intuitively want to believe that this instruction will create an entirely new copy, whereas in Python it does not. So here we can see that list 4 has indeed been extended, and as list 4 is a part of list 7, the object inside list 7 has been extended. And we can take this further. So we can extend the second level nested list with a third level list. So we can type list 5, extend list 1, and we can print list 7. So here we have list 5, and it will be extended by list 1. And list 1 we have here. So let's run this code. And here we can see that list 1 is now a part of, you could say, list 5. And it also brought its string with it. What we will do now is that we will show you how to access third level objects. We type print list 7, 1, 5, and 2. And this will point at this object first. And 5 will point at this part of the object, the third level. And 2 will point at this number. So let's run this code. And here you can see that it printed the integer 7. And now we'll show you how to access third level objects with a for loop. We type for x in list 7. Print x. And as you can see, we use the same part of this nested list. So here we point at this object and we point at position 5, which is this nested list. And now we'll print it using a for loop and a print instruction. So let's run this code. 1172 and so on. And when we print this, they all appear as strings, regardless if they are integers or strings. And this list notation, where we point at the position in the lists and the number of lists which you can nest inside other lists, are only limited by your ability to type finite numbers. However, it must be said that these multidimensional lists become very unwieldy quickly. So it's considered Pythonic to not use more than at maximum 3 nested lists, and preferably use as few nested lists as possible, because it can quickly become very hard to read and understand. And most brilliant people can only visualize in their brain volumes. They can see 3 dimensions, but they can't see 4, 5, 6, 8, or 9, or even more, which could be worse. But most brilliant people can see 3 dimensions. And most educated persons can see 2 dimensions. But almost everyone can see 1 dimension. And this is a great reason to limit the number of dimensions when you have the option and creates this code. Because one day someone else might be using your code. And then it can be advantageous if that person can read and understand the code. So this was some words of wisdom about what is Pythonic and what is not Pythonic in the perspective of Python lists. So right, this has been an exciting video lecture about Python lists, and now you know how to use and handle Python lists for data handling and also applications. You have had a great, possibly one of the best introductions to the very useful Python lists available. And in the future videos, we'll teach you even more. And we look forward to see you in the next video.